Hi buddies, welcome to my channel. I like to do Love Babbar DSA sheet. I gonna start from the arrays. So I think it would be helpful for those who learning DSA and started learning DSA. So I'm not going to learn tell the entire data structure things, but I'm directly doing the problems as I know about them. But if you don't know about the data structures, please go through the data structures, then start doing uh, problems, because without knowing the data structure there is no point of doing the problems. So let me start with the first problem in the Love Babbar sheet. So the first problem is find the duplicate. Since I already completed this problem, let me explain you what's the exact um, logic behind the problem. Here they given an array of integers, array called nums containing n plus 1 integers, where each integer in the range of 1 to n. The question is clear, right? For example, here the n is 5. So the numbers in the array should be below the 5 in the range, or 5 or below 5. So here the 2 is repeated 2 times. So we should return the value which is repeated 2 or more times, since we have to completely understand the question, because we have to go through the question completely. There is only one repeated number in the nums, since it mentioned there is only one number repeated in the arrays. So we have to return that repeated number, and you must solve this problem without modifying the array. So we should not modify this array, and we have to return that repeated number. The most important part is using only one constant extra space, nothing but we should return the solution with order of one space complexity. So this is the most difficult part, or else for a brute for purpose we can go for a for loop, and we can check, right? So but here the situation is different, the problem statement is different, because we have to return the solution with order of one space complexity. Here, as we go on to the second example, here it is 3 1 3 4 2. Here the 3 is repeated 2 times, right? The same way we go for the third example, the 3 is repeated for the 5 times, means 3 is the duplicate value, we have to return the 3. And we will go to the constraints, and the n values are always less than 10 power 5, and it's maybe always greater than or equal to 1. And coming to the all integers in the nums appear only once except the precisely one. Here mentioned clearly that only one number is repeatedly repeat, but it may be 2 or more times. So we understood this problem statement completely, but we have to go for the logic. But everyone, when they go through this problem, they will get the hash map is the solution. Yes, hash map we can make the solution with the hash map, because this is a key value pair. In the hash map there is a key value pair, so we can store the key and the value as a number of repeated times. But it would take more than order of one complexity, since we are storing so many keys and their values. It is not, we can do it order of one with using hash map. So we should not use hash map. So what should we do to complete this in order of one square? Yes, there is an algorithm specified for this type of problem statements. Let's go with that algorithm first. So here, Floyd's cycle finding algorithm. Here it is also called as Harry tortoise algorithm. It is a very important algorithm. We also using this algorithm in not only here, we also going to use in linked list also. So actually the algorithm simply itself, it's using two pointers. Let's assume here is a pointer and tortoise is another pointer. The slow pointer is nothing but the tortoise. The fast pointer is nothing but hare. Hare is nothing but, just assume it as a rabbit, which can jump speedily, which can move speedily than tortoise. So here the same concept is applied in the algorithm. The first pointer, slow pointer, slowly moves step by step, whereas hare, and nothing but the first pointer, moves quickly, jumps two steps at a time. Just assume two steps at a time. So when they're moving, the slow pointer moving about step by step and the fast pointer moving two steps at a time, then they when they move in this range, they will meet at some point. If there is a loop, if there is a cycle, they will meet at a point. This is a simple logic of this algorithm. So we are going to use the same algorithm in this problem, which is we took from Love Babbar sheet, the first problem, and which is in the lead code with ID 287 problem. Find the duplicate number. We are going to use this fluid cycle finding algorithm. So I explained the problem statement and we understood which why we should use this cycle finding algorithm and what is the logic behind this Freud's cycle finding algorithm. Since we have to use two pointers to find the loop, right, to find the cycle. Here clearly mentioned the first pointer may reach the end, which shows that there is a no loop in the linked list. The first pointer again catches the slow pointer at the same time, therefore a loop exists in the linked list. But we are using this same concept in the arrays. See, if while traveling the list, slow pointer will move one step at a time. Fast pointer moves two steps at a time. I explained you it before, right? In the same way, if there is a cycle, the fast pointer will eventually catch up with slower pointer with the cycle because it's moving faster, right? If there is no cycle, the fast pointer will reaches the end such that the fast pointer and slow pointer will never meet because there is no cycle, right? When the slow pointer and fast pointer meets, a cycle or loop exists. You understood, right? I hope you understood this thing. So uh, let me go back to our problem statement. Hope you understood the algorithm. So I took the slow pointer has the nums of 0. Here the slow pointer and fast pointer not indicating the index values clearly mentioned here. It indicates in the value in the index. For example, I am assigning the slow to the value at the index 0 of the nums. So it would be someone, let's assume 1. But the fast pointer is indicating the value of the index of at particular index 0. For example, let's say what's the nums of 0 here? Nums of 0 is 1. So we are storing one value in the slope. That is all right, right? Now in the fast pointer, we are storing the value at index 1 because nums of 0 is 1. So again, nums of 1 is 3. Okay, we are assigning 1 to the slow and 3 to the fast. Since the slow is takes only one step, right? One step means it will stores the value 1, but the fast pointer can have two steps at a time because so two steps at a time, so it's storing the value of a particular index, so it's storing the value of 3. So in the same way they will move until the values of the slow pointer and fast pointer is not same. So while slow not equal to fast, here the slow is equal to nums of slow. So nothing but it's moving only one step at a time. Okay, so the value will move to, since here the value is 1, right? Initially slow value, so value is 3. Hope you understood. Hopes it makes a sense, right? So since 1 is not equal to 3, the loop will continue. Now slow is equal to nums of 1, nums of slow. Since the value of slow is 1, right? So nums of 1 here, nums of 1, nums of 1 means again here you going to take index. Nums of 1 index is 3. Slow becomes 3. You understood, right? In the first iteration only fast took the value 3 here, but in second iteration the slow is taking 3. Now we'll go for fast. Fast equal to nums of fast. Here the fast value is 3. So nums of 3 is 0, 1, 2, 3. Nums of 3 is 2. So, okay. Here here the value will be 2. So nums of 2 again 0 1 2 4, the value becomes 4 here because the first pointer value becomes 4. So since 3 not equal to 4, again we are going to iterate one more time. Slow is equal to nums of slow. Slow is 3 0 1 2 3, right? The value at 3 is 2 0 1 2 2. Again the fast is 4, right? 0 1 2 3 4. Nums of 4 is equal to, so nums of 2 0 1 2, again here 4, right? Here again it's coming 4. Since 2 not equal to 4, again one more iteration. Slow not equal to fast, right? So slow equal to slow of 2. Here the value is becomes 4. Nums of 4 0 1 2 3 4 2. Nums of 2, again it becomes 4. Now the values are equal. It's not showing that the repeated integer, it's just showing there it's the loop started. So now we are making the one of the pointer to 0 and we are start iterating again. Since the slow pointer is at where it is at 4, right, at index 2, and the first pointer is also here. So we are making one index, one pointer to 0 means nothing but it indicates to 1, and we are iterating step by step. Look here, we are stepping two indexes at a time. Here means nothing but 2 steps at a time, but it coming to here we are only stepping single step here to find where the repeated number. This loop is to find whether there is a cycle or not. Yes, there is a cycle, but here we are finding what is the repeated one, repeated integer over here, right? So uh, be careful, listen here the exact point what I'm going to say, because the slow is not equal to fast. I'm looking for the same thing again, same logic, but now I'm jumping step by step, not here like jumping 2 steps at a time. The first point I'm talking about first pointer. So slow is indicating 4, right? Slow indicating 4, but here the first is indicating 0. Since slow 0 not equal to 4, right? I make the first to 0, 0 not equal to 4, right? So the loops will run. Slow equal to nums of slow. Nums of slow means nums of 4. Nums of 0, 1, 2, 3, 4. Nums of 4, 2. Slow becomes 2. Next, it indicates 0. Okay, 0. First nums of 0, 1, right? 1, it becomes 1. 2 not equal to 1. Once again, the loop will jump. Okay. Slow is equal to nums of slow. Slow is equal to nums of 2. Nums of 2 is 4. So slow becomes 4. So fast equal to nums of 1. Nums of 1 is equal to 3. So fast becomes 3. Now 4 not equal to 3. Again it will runs. Okay. Slow is equal to nums of 3. Nums of 3 is equal to 0, 1, 2, 3. 2. Slow becomes slow becomes 2. So again the fast is 3, right? Fast equal to nums of 3. 0 1 2 3, right? Nums of 3 is equal to fast. What is the nums of 3? 2. Okay. So the values are stored here. Slow equal to 2, fast is equal to 2. So here the values are made. The loop is going to end and we are returning the value. This is the simple logic behind this problem. Hope you understand. Thank you. Please like and subscribe.